Let's look at critical values of a function. Now, here we have the graph of a function. And by the way, the book I'm using here, the PDF document of the book Calculus and its Application, 10th edition. Right, a very good book. I encourage you to download it. If you're studying calculus, you can also purchase the printed copy on Amazon or elsewhere. But let's go back to what we were looking at. Where were we? All right. So we're saying critical values. We have a graph here. It's a general graph of various functions. F of x is 0 at C1, C2, C4, 7, and 8. That is, the tangent line to the graph is horizontal. You can see the tangent here. So tangent line there, horizontal. All right, these are horizontal lines as well as here. Now, f of f prime x does not exist at x equals c3. This is vertical. You have a point of inflection here going up. The line through it is going upwards. C5. So C5 is a corner, a sharp corner right here. C6. Yes, you have another sharp corner at C6. So the tangent line is vertical at C3 right here. And there are corner points at C5 and 6. All right, now C1, 2, 4, 7, and 8 are called critical values. 1, 2, 4, 7, 8. That's 1, 2, 4, 7, and 8. These are called critical values. F prime of C is 0 for each of these. C3, 5, and 6 are critical values because f prime of x does not exist for each value. C3, 5, and 6 are critical values. 3, 5, and 6. C3, C5, and 6. That's where the tangent line is vertical, or there are corner points, are critical values because f prime of x does not exist for each point. Also note that a continuous function can change from increasing to decreasing or from decreasing to increasing only at critical values. So in the graph, C1, 2, 4, 5, and 6, and 7. C1, 2, 4, 5, 6, and 7. Separate the interval over which a function changes from increasing to decreasing or decreasing to increasing. Now, although C3 and 8 are critical values, C3 and 8, there is no change from increasing to decreasing at 3 and 8. You can see that here. Although C3 and C8 are critical values, they do not separate interval over which a function changes from increasing to decreasing or decreasing to increasing. Right. So there you have that. Now you have these peaks and the valleys. Notice in figure 2 the peak and the valleys are at the interior points C1, 2 and 3. C1, C2 and C3. So you have a valley here, a peak here and a valley. The valleys are the relative minimum. This is a relative minimum because it is a minimum but it's not the lowest minimum. This is a relative maximum point because it is a maximum but it's not the lowest. So here, this minimum, if you project across, there are points lower than it. This maximum, if you project across, you see there are points higher than it. So this is relative or local maximum, local or relative minimum. This is an absolute maximum because it's the lowest point on the graph, no matter how far you go to the left or right. If you tend towards negative infinity, you will never find a point lower than this. Absolute minimum. This is an absolute maximum. Alright. Now the thing is, with this curve, you start at A and you stop at B. The highest point of all is here, so it's an absolute maximum. The lowest point of all of them is here, so it's absolute minimum. Alright. Now, we have f of C2 right here. It's an example of a relative maximum more than one maxima, one maximum more than one maxima. And each of FC1 and C3 right here and right here is called a relative minimum. One minimum more than one minima. The terms local maximum and local minimum are also used. So relative or local, you can use whichever one you want. Right? Now, a relative minimum can be thought of loosely as a second coordinate of a peak that may or may not be the highest point. Similarly, a relative, let me read that again, a relative maximum can be thought of loosely as the second coordinate of a peak. That means the first coordinate is the x, the y. This second coordinate is the y. The y coordinate of a peak, you're going up to a highest point and then go down, but that may not be the highest point when you consider all of the curve, right? It may or may not be the highest point. So it's relative or local. So it's the highest point when you consider the surrounding close to it. But if you go far away, you might find other points higher than it. Like this. It's the highest point here. But when you go further, you see higher points than it. And then the second coordinate of the points that are highest or lowest are relative. Oh, we were here. Where were we a while ago? Right, we were here. Similarly, a relative minimum can be thought of as the second coordinate of a valley that may or may not be the lowest point. So this is a valley, this is another valley. This one is relative because if you go further and further, you meet after a while you meet some point that is lower than it. So it's relative minimum. The second coordinate of the points that are the highest or the lowest and the interval respectively are the absolute maximum and the absolute minimum. For now we focus on finding relative maximum or relative minimum values, collectively referred to as relative extrema. Singular is extremum. One extremum, more than one extrema. Alright, so these are extrema, extreme points. So these are extrema. Alright? Alright, so we'll break this video at this point and continue looking at this topic in another video.